Okay, hello, good afternoon. Right. So, today, on Friday, we'll be talking about Davidson's reality without reference. Let's just move straight into the topics we were looking at. Okay, in the very first meeting of this class, now I keep going back because according to different people, all the key mistakes were made in that first meeting. So in the first meeting of the class, I said, well, what is it that's special about a language? If you're looking at sounds or sign systems that some animals or people seem to be using, and you're saying, is that a language? What would it take for it to be a language? And I said, okay, our working definition is you've got a language when you've got sentences that can be true or false. When people can make statements that are true or false, that's a language. And then I said, well, a language is complex. What I mean is that the sentence is complex. The meaning of a sentence depends on the meaning of the parts. And in particular, what it takes for a sentence to be true or false depends on some characteristics of the parts of the sentence. And I said, well, you've got notions like reference, or whether a predicate applies to an object, whether a general term applies to an object. And they give you an analysis of what's required for the truth or falsity of a whole sentence. So just to make this a little bit more explicit than we have so far, suppose you have a language that has just two names and two general terms in it. Okay? So it has the names Rolly and Isaac, and the general terms smokes and fishes. So you can't do a whole lot in this language, right? I mean, you say Rolly smokes, and I say, well, Isaac smokes, and you say, Rolly fishes, and I say, Isaac fishes, and then we kind of shut our bolt. That's about as far as we can go. We just have to go back to the beginning and start again. So it's not really Oscar Wilde, this kind of thing, but it's a language, right? So 4 sentences, 2 names, 2 general terms, and you can make very explicit how this language works. When you say Rolly fishes, how come that sentence can be true or false? What explains the fact that that sentence can be true or false? Well, it's that the name Rolly refers to Rolly, and the general term fishes applies to an object just in case that thing fishes. I don't say this is great progress, but that's the explanation of why the sentence is true or false. And then the move was, and now how can we deepen this explanation and give a theory of what reference is, or when a predicate applies to an object? I mean, you might say, well, there are only finitely many sentences here. There are only 4, in fact. So couldn't we have a language with lots of sentences in it? I mean, you can get that quite easily. Suppose you introduce the term and you say, what does it take for a sentence of the form A and B to be true? Well, if you have a sentence of the form A and B, then that's true if the first sentence you use is true, and if the second sentence you use is true. Right, so now you know what that means. And now we can have infinitely many sentences, and now we do have infinitely many sentences in our language. You say Rolly smokes, I say Isaac smokes. You say, aha, Rolly smokes and Isaac smokes. And I say, Rolly smokes and Isaac smokes and Rolly smokes. And you say, Rolly smokes and Isaac smokes and Rolly smokes and Isaac smokes. Okay, we can do this for quite a long time, right? So now we have infinitely many sentences in the language. That was quick. I mean, that's a language. And the great thing about it is we understand how it works. You have a sentence of the form A is if. That's true if and only if the predicate applies to whatever the name refers to. So if you've explained the truth or falsity of the sentence, you explain the truth or falsity of the sentence in terms of what the predicate applies to and what the singular term refers to. Okay, so we've broken down our initial problem a bit. Now, the idea of a causal theory of reference is, it looks like, I mean, what Dretschke and Fodor are thinking is, we can take this a lot deeper. Suppose we can give a causal analysis of reference in something like the way Dretschke or Fodor wanted to. So you explain what it is for a singular term to refer to an object in terms of some kind of causal connection between the name and the object, and you explain what it is for a predicate to apply to an object in terms of some causal connection between a property out there and your use of the term. Then, those are physical notions, causation. Physicists can make sense of this, can describe the causal pathways to you. So it looks like we've broken down the truth or falsity of a sentence to the references and application conditions of the parts, and that gives us a kind of microscopic analysis of the truth or falsity of the sentence. And now we've deepened that by giving a physical analysis of the notions of reference and the application of a predicate. You might think there's a parallel here with the way that chemistry and physics are related. Let me just say, incidentally, this is a very simple theory for a very simple language. To do that for the whole of English, to show for every sentence how its truth or falsity depends on the references of the parts, is really not trivial. Right? That'll be a major project to just keep doing that. Right? And indeed, through the 1970s, and indeed even still today, there are many people who think that's what philosophy of language is giving this kind of breakdown for ever more complex reaches of English. Okay? So although what I'm doing here is very simple, the general project is not at all trivial. And then we deepen that whole explanation here by looking at the causal connections between the elements in the world. So you might think there's an analogy here between, here's my understanding of what happened in chemistry around 1900. It's something like this. There aren't any chemistry majors present. Okay. My understanding of chemistry peters out at high school, so I hope you may be able to help me with this. But it's something like this. When you're asking how chemical elements combine with one another, you can give each element a valence number. And then, when you know the valence numbers of all the elements, you can make predictions about the proportions in which the elements will combine to form compounds. So you can just read, so there are laws governing the interaction of chemicals stated in terms of valence numbers. You can say, well, that's fine, I've got these, how should I say, phenomenological laws that describe the data about how the chemical elements combine. And if you say, why do they combine in these ratios? Well, it's because they have the valences they do. But that's not a very deep explanation. And you can deepen the explanation by going beyond the just saying, well, there's the valence of the element. You can say, how does that chemical level of explanation, how does that notion of valence connect to physics? How does that connect to the description of an element that physics gives? And my understanding is that you can give a definition of valence in physical terms, that the valence of an element is the number of gaps in the outer electron shell. Something like I should have put that more authoritatively. It's quite clear that nobody has any idea about this. Take it from me. When you get the atom, the atoms that constitute an element, there are gaps in the outer electron shell. The number of gaps in the outer electron shell can just be identified with the valence number. And then when you're getting a compound forming, when you have two elements interacting, what's happening is that those atoms are connecting and bonding together, as it were, to form molecules. And the proportions in which they combine depend on the numbers of gaps in the outer electron shells, because that's where they kind of lock onto each other. Don't say you don't learn anything in this class. Okay, but you see what happened there. I mean, something, I don't know about the details, but something like that is certainly correct. Right? Now, what happens there is you have laws of chemistry, you have laws governing the interactions of elements, stated in terms of valence. They're in a way relatively superficial. And what you do is you deepen your understanding of what's going on here by connecting this to physics. You say the general laws governing all of the physical particles explain why the elements are combining in the ratios that they do. So you can think what we've got going on here with language is kind of like that. There are these general laws explaining the truth conditions of whole sentences in terms of the references of the parts. So the truth conditions of the whole sentence is like the ratios in which the elements combine. And then giving references to the parts is like saying this is a valence number. And you can explain how come this whole sentence is true or false in the circumstances it is true or false by appealing to this idea that the parts have references. And then you can say, now what has all this got to do with physics? And you can deepen the explanation. You can define reference in physical terms. That was the Dretschke-Fodor idea. Define reference in physical terms. And then the laws connecting truth and the laws relating truth and reference will all be explained in terms of the general laws of physics in the end. Language will just be a special, yet another physical phenomenon. So you explain the laws of relating truth and reference in terms of basic physics. I mean, it's not obvious what else you might say here. I suppose it had proven impossible to explain valence in terms of physics. You couldn't, there was no such thing as physical chemistry. You couldn't explain the notion of valence in physical terms. That would be really weird. There would be an aspect of reality, the chemical aspect, that was just not physical. Valence would have nothing to do with what was on in physics. There had to be a definition like this, really, if it's just one physical world. So if you're going to say, we explain truth conditions in terms of references, but that's not to be defined physically, that makes it look like we're just dealing here with some non-physical aspect of reality. So something like the Fodor-Dretschke approach has got to be right. Unless we're going to be dualists and say that a lot of the law is not physical. Yep. Mm-hmm. Yes, right. Well, why would that be? I mean, well, what I mean is, suppose you take something like, Fodor on horse and cow and so on, right? So you say, well, the reason the word horse has the reference it does is that's what causes its use. This physical phenomenon is what causes its use. You can describe the phenomena there in microphysical terms. Is these physical things causing there are streams of particles involved? Yeah. So even if you look at the microphysics there, you still see roughly what's going on in the causal patterns. Yeah. So in this approach, the theory of meaning would be like chemistry, basically. It would stand to physics pretty much the way chemistry stands to physics. But as we saw, this is a very difficult line to take. It's very hard to explain how the mere existence of causal connections between signs in the world could generate standards of truth and falsity. But that was as far as we got with Dretschke and Fodor. You say, I mean, it's one thing to say, well, when the atoms lock together, then the elements combine in the ratios they do. You can see how that whole thing works. But what you're being told here was, when you have an asymmetric causal dependence, or you have one sign's function being to indicate something, then you can see how you get standards of truth and falsity. But the basic puzzle was you don't see how that happened. Where did the standards of truth and falsity come from? How did right and wrong get in? That was just fundamentally baffling. That was when we shifted gear and started looking at Wittgenstein to see if that might help. Well, Davidson has a quite different take. Davidson says this whole way of setting up the issues is wrong. Davidson says we should be instrumentalists about the explanation of truth conditions in terms of reference. So let me just go over what instrumentalism is. Well, one analogy you might have here is the way they thought about Ptolemaic astronomy in the Middle Ages. So people have been doing astronomy for a very long time then, right? I mean, astronomy was, I guess, was it the very first science to get going? I mean, frankly, because it's the easiest. I mean, you've got the you have the patterns of stars in the night sky, and it's a pretty straightforward, compared to other kinds of science. You just look at the stars in the night sky, note where they all are, and then try and generate a system that will predict where they'll all be, what you'll see tomorrow night. So the people have been addressing that problem for centuries by the Middle Ages, and they thought that everything went in perfect circles. So if you assume that everything goes in perfect circles, well, it doesn't come out right. I mean, your predictions as to where everything will be tomorrow, that doesn't come out right. So they said, well, maybe they're moving simultaneously in more than one circle. So it's something a circular motion like this, but at the same time it's also describing, this whole thing may be describing a further circle, a further larger circle. So you're moving in this circle, but at the same time rotating around a large. And maybe you're actually doing that more than once. You see what I mean? So that this can get pretty complicated. And by the Middle Ages, they did have theories that were indeed very, very complicated, but actually predictively completely correct. They were completely accurate in describing what's going to be happening next in the night sky. So they could predict eclipses, for example, pretty well. But nobody thought this whole complicated business of circles upon circles was giving you a picture of the dynamics of the situation. Nobody thought this is a causal explanation of what's going on here. They thought this is a really great way of predicting what you'll see. It's a handy gadget. It's literally like an abacus. I mean, they built models. There are many models surviving today of these predictive devices for telling you what you're going to observe next. But it's not really explaining why the stars are in the positions they are. It's a convenient fiction. It is an abacus for making a prediction as to what you're going to see next. So that's not explaining anything. It's just a gadget for predicting what you're going to see. So if you had one system of epicycles for predicting what you're going to see in the night sky, and another system of epicycles for predicting what you're going to see in the night sky, and they make the same predictions, then there's no difference between them. I mean, they're just two gadgets for cranking out predictions. It's not that they're disagreeing about what's fundamentally going on, because neither of them is saying anything about what's fundamentally going on. And that was actually the position that the church recommended to Galileo when Galileo said, no, the earth is moving. They said, that's great. You can really do something with that idea that the earth is moving. They said, look, you can predict the positions of the stars in the night sky using this idea that the earth is moving. And you can do it just as accurately as we can with the old epicycles. But you don't want to take this too seriously. They're not really in competition. They are both just instruments for cranking out predictions as to what you're going to see next. They actually crank out the same predictions. Therefore, there is no real disagreement between them. Why not take that line and let's call it a day? And he said, no, actually, I do disagree. Up to a point. Yeah, but if you're taking that view, that you're instrumentalist about the movement, about the epicycles and so on, then, and you say, but what is the circular motion really? What is causing the circular motion? Can you give me what does it mean to say it's going in these two circles simultaneously? What are the causes? Well, there's no point in trying to go that deep into it. The thing doesn't have any depth in that sense. All that there are the surface appearances and this way of generating them. The only physical reality here is the observed positions of the planets in the night sky, and you get your gadget for making predictions. Now, if you apply that to talk about reference and truth, then when you have this kind of little theory, when you say Raleigh refers to Raleigh, Isaac refers to Isaac, and so on, right? And you say, and now the whole sentence is true if and only if the general term applies to whatever the predicate refers to. You say that's like the Ptolemaic epicycles. That's just a gadget. That's just a convenient fiction for cranking out predictions as to when a whole sentence will be true or false. That's the reality, the truth or falsity of whole sentences. This kind of thing, this kind of theory about the references of the parts, that the sign is hooked up to an object, that the predicate applies to something just in certain conditions. You don't want to take that too seriously. They're like epicycles. You don't want to say, but what is this really? What is actually going on here? There isn't anything actually going on here except the fact that whole sentences can be true or false. So in this kind of picture, talking about reference is just an instrument for predicting the truth conditions of sentences. You don't even need a physicalist account of what reference is. Reference is no more an aspect of reality than the epicycles are. And if you have two different theories, two different ways of saying what the references of terms are, that crank out the same predictions as to when whole sentences will be true or false, there's no difference between the two theories. There are no facts of the matter at the level of reference. So you don't need any account of what reference is. I actually told you the whole thing about what reference is when I gave this kind of theory and explained how it hooks up to the truth conditions of whole sentences. There is no more to be said about reference than that it plays this role in cranking out predictions. So everything we've done from Frege, Russell, Kripke, Grishke, Fodor has all been a mistake. Right at the start of the class, I said, look, you've got to connect between the name and the object. And what is that? If we can characterize what's going on there, then we're making progress. And then you say, well, maybe it's a causal connection, or maybe it's a descriptive link, maybe something like that. That's how the connection between the sign and the object is made. You say, now is that connected between the sign and the object physical or non-physical, or what is it? And the answer is, it's not any of these things. There is no need for a definition. It's not like valence, where you want a deep definition. It is just a predictive gadget. It is just a bit of gas, a bit of hot air that you use to help you characterize the empirical reality, which is that sentences can be true or false. You don't need an account of what reference is beyond an account of the role that reference has in generating statements of the truth conditions of sentences. All the problems we've been dealing with so far have come from letting reference take on a life of its own and then puzzling over it, but we shouldn't have been doing that. That's Davison's basic move in this paper. Yep. Yes. Right. Yep. It does or doesn't seem. We don't appeal to these models. You mean like this? This kind of model. You're saying we don't appeal to this kind of model? Ordinarily. Yeah, I agree. That's a natural interpretation of it, right? And that's the kind of interpretation of these kind of statements that we've been working with all the way through in this class. But I guess I don't yet see why it has to be like that. And you're saying if we give this predictive model, it has to be an explanatory model. Yeah. But why couldn't it be predictive without being explanatory? It's not meant to explain anything. It's just, well, why couldn't it be just a gadget, a convenient fiction? Let me give one more analogy. People sometimes say, think of electricity as if it's a fluid, right? And this is kind of my level of understanding of physics, but anyway, and you imagine that the different kind of wires that it goes through are pipes of varying diameters, something like that, under the pressure of it, right? Now, if you think of the electricity like that, then you might be able to predict how much current a wire will take, what kind of fuse you'll need in a particular circuit. You do quite a lot with that kind of model, but it's just predictive. It's not trying to analyze or explain anything about what's going on in the wire. It just says, here's where this wire will melt, here's where this wire will take the current, that kind of thing. Why can't this kind of talk be like that? You mean in ordinary talk, just ordinary humans don't appeal to this kind of model?